So welcome to the meeting tonight. My name is Eric Veal and want to welcome you guys to Space Data Hackers. This is July 2024. And tonight we have Umbra Space presenting, and they're going to talk about synthetic aperture radar. So first, just kind of welcome to everybody that's come. Appreciate your time. Just a quick one for anybody that is joined. Where did if anybody wanted to come off mute, or where they heard about Space Data Hackers originally, or how you found this group? Just a quick kind of round robin, maybe on for a minute here. I'll call on people. Daniel, how about you? How'd you find out Space Data Hackers?
From Mike.
Okay, and you know Mike personally?
Well, no, from NASA Space Apps.
Okay, very good. How about you, June?
Yeah, I actually can't remember where I heard about it exactly, but it had to be somewhere online. I used Meetup for a while, but yeah, I was online and I connected with Mike and did Space Apps as well.
Okay, and another Mike, but Michael Patrick. How about how'd you figure it out?
So I'm a geographer, geographic information systems, been doing Landsat as far back as like the 80s with Landsat. Very sporadically, it's not a full-time job or things like that. And I've participated in many of the NASA hackathons, space app hackathons, and other ones like the Defense Department, things like that.
Real good. How about you, Andrew McKenzie? I think let's move on. I don't want to drain this too much. So I'm Eric Veal. The Mike that was mentioned earlier there by a lot of people is Mike Doyle. He's the president of Space Northwest, and friend of mine, and somebody that's really kind of the host and sponsor of this broader community. So we're thankful for his leadership and just, I guess, vision to bring us all together. And I found out about this group about a year ago through my friend Shalom, who knows Mike, and started talking. And I was kind of in between groups, I guess. And I thought, hey, why not study this particular topic? So that's this. And so just quickly about Space Data Hackers. Space Data Hackers is a community for people who love data in space. We explore data sets capturing space. Again, won't read the whole slide for you here, but tonight we have Kyle McCloud from Umbra Space, who's going to talk about synthetic aperture radar and teach us about that. Hopefully enough 101 that anybody that's new to it can just figure out the basic topic, and then we can go from there. And so our flow tonight is just kind of some welcomes here and a little bit of information just about some other kind of related groups and just a few commercials, so those aren't forgotten. And then we'll get into Kyle, and he's kind of got the floor for as long as he wants it, and then we'll kind of debrief after that and wrap it up. So appreciate everybody for coming. So just a quick little plug here for our Meetup site. You can find us on Meetup, just Space Data Hackers. And really, to me, the best place to figure out where or when our upcoming events are. Sometimes they're usually on the last Thursday. Sometimes they're on Wednesdays like tonight. So thanks for your flexibility in figuring us out. A couple other just kind of plugs for other things that are related here. Space Northwest Alliance is another one. So definitely check out spacenorthwest.org for more information on this, if that's something that interests you. Another plug, volunteer with Space Northwest. We're always looking for volunteers, so please reach out to me or Mike Doyle. You can see, I'm really the address that we're plugging here is just info@Space Northwest. So send us a note, say hi, let us know what you're thinking or how we can help you. And we're definitely a service org and just want the best for everybody that's involved here. And a quick plug for next month. So August is AWS, so Amazon Web Services, Space and AI. Mike Doyle's day job is at Amazon, and you kind of can't live in a Seattle area and not know a lot of people that work in the greater Amazon sphere. So that's that. So join us next month and check us out on either spacedatahackers.com or Meetup for the details on that. And so tonight, would like to welcome Kyle McCloud, and he's our speaker today from Umbra Space. And I think at that, I'll just hand it over to you, Kyle, and you can take it away, and we'll just check back in when you're done.
Sure, I appreciate it. I'm gonna share my screen. Well, it says you've got screen sharing disabled, unfortunately. We'll get her.
Yes. There we go. Who can start
There we
sharing?
go. All right.
Get it good.
All right. So, hey, thanks for having me here tonight. Like Eric said, my name's Kyle McCloud. I'm customer engagement manager here at Umbra Space. My role is an interesting one. I serve in a position where I get to act as kind of that conduit between our customers and our product teams back at home base. If you haven't had a lot of uh, interaction with Umbra, we are synthetic aperture radar imagery company. We are based in Santa Barbara, California, but we have folks all over the place. I personally work remote from just outside of Augusta, Georgia. Prior to coming to Umbra about a year ago, a little over a year ago, I was an imagery analyst. I spent 11 years active duty Navy, and then 9 years as a contractor for the U.S. Army at Fort Eisenhower here in Augusta, Georgia. So Umbra was gracious enough to bring me on board last year, put me in a role where I get to run around and talk about the cool things that we're doing with satellite imagery, particularly with synthetic aperture radar. Let me see. That's switching the slides, right? Perfect. All right, so a little bit about our company. Umbra has taken some positions that at times are seen as a little bit controversial in the space industry. We have decided that we have transparent pricing. Mike and I were talking about this just before we started, how he in the past had looked for pricing through Airbus and other systems and couldn't find it. We are fixing that for you. You go to umbra.space and we have the pricing right there for you, transparent pricing. Additionally, we have Creative Commons licensing, which means you buy the imagery, it's yours. You can share it, you can put it on Twitter, you can draw all over it and sell it as an analytic product. It's yours. Additionally, we're taking steps to make it easier to use our data. Synthetic aperture radar and satellite imagery in particular is difficult to get your hands on. We have created an awesome customer-facing UI that I can demo if we have time, and also added API tasking. So Joe Morrisor, I saw popped up on here, has been quoted as saying he wanted to make tasking satellite imagery easier than booking an Airbnb, and I think we've succeeded. We've got a great team here doing that. So far to date, we have put 8 satellites in orbit. We currently have 5 that are commercialized, and 2 more going up on rideshare soon. We utilize SpaceX's rideshare program for all of our launches, and we have, again, 2 more birds going up, hopefully in the next month or 2. With that, Mike and I were also talking about open data. If you go to our website again, umbra.space, we have a huge open data program. I know the slide says we have 3,000 data sets, but I think we had a customer tell us last week he actually went through and counted, and we're up to, as of last week, just shy of 5,000 data sets in our open data repository. Our team, we've chosen to stay lean and mean. We have approximately 130-ish employees, with 10 of us that are cleared with top secret security clearances, and spend a lot of time facing U.S. government utilizing that. And please, at any time, feel free to stop, ask questions. I like to keep this pretty freewheeling, as I do many of my presentations. So if there's something on a slide that I don't go over, or a question you have, please stop me and I'll go over it.
How big is the eventual completion?
So,
You have now.
we do everything based on user demand. So right now we have a plan for up to 13 satellites. But we will expand that as we build demand, both in the commercial and government sectors.
So are you guys like using weather balloons to launch the satellites?
No, we're using the SpaceX Falcon 9s to launch them into low Earth orbit, approximately 550 kilometers or so into space.
Uh,
And here, and a
so
little bit
you
of
guys
details
are
about
a
our satellite.
commercial company?
Say again?
You guys are a commercial company?
We are a commercial company. Yep.
Uh,
Looking at our technology, we are X-band satellite, which is like the most common. Both of our competitors are shooting X-band synthetic aperture radar. Our systems are built and designed differently, however, in that they're designed to capture a large amount of data in a small area while also being high resolution. So we are currently commercialized to 25 centimeter resolution. Our NOAA licensing allows us to go lower than that. We've done some R&D down to 16 centimeters and posted that on Twitter. But it's not something we've commercialized yet, going that high resolution. But our systems are highly maneuverable. Each satellite is built to support imaging up to 500 images a day. Multiply that by the 5 that we have commercialized now. We've got a ton of capacity, especially depending on where on Earth you're looking. Also, our satellites are in a polar orbit. Polar orbit, which means we get we don't get repeat ground track, but we get about 2 passes a day over most areas with each satellite, which isn't too bad. We're working on getting repeat ground track, which will allow things that I'll get into in the future slides, like change detection and things of that sort.
So, and just please tell me if I'm probing where I shouldn't. Where does the power come from? Because I'm just looking at the solar panels, and do you have to task around the power demands? Is there a power budget to consider when tasking?
There is. We have a really robust duty cycle though. So we do have to take some time to flip the bird and have it facing the sun. But our system is still designed to capture a ton of imagery. Again, the power we have on board with our battery system capable of 500 images a day per bird. And that's taking into account having to charge things back up. All right. This is just a demonstration video that we put together highlighting those high volumes. And this is the animation is obviously something we did after the fact, but this was a single pass with a single satellite hitting Japan.
Kyle, there's a question from Resrick. Resrick, you can unmute. Go ahead, sir.
Say again?
Yeah, I didn't want to interrupt. So you said it's powered by like batteries. So like what kind? Is it like you got like using nuclear batteries, or what kind of batteries are you using?
That
Lithium?
I can go back and ask our tech team. I should have caveated at the beginning. I'm not an engineer. I don't build the satellites. I've seen them. We build our satellites in Santa Barbara, California. I've seen the satellites as they're being built, but I don't know tech specs, and I do apologize. But I can ask those questions and kind of get back to Eric and Michael on that.
Kyle,
All
how
right.
big is one satellite roughly? Just curious.
Say again.
How big is one satellite roughly?
Approximately 78 kilograms. So we tell people you could fit it in a medium-sized trash can if you wanted
It's
to.
a tiny little guy.
Yeah, and our antenna is 3.8 meters. So we've got patented technology that enables that antenna to fold out or to fold for launch.
You have an animation of any kind of the deployable? It looks really cool.
That I don't.
Okay.
It's something we are working on. I was actually just talking to the marketing team earlier today, and they're putting some stuff together. So we'll be able to see just that, an animation of it deploying the antenna.
And Kyle, note just to set your expectations, like no pressure for following up or that you owe us answers to every question we can throw at you. So no pressure on that.
Okay,
Appreciate
no
it.
worries. Coming from my military background, they always tell you don't say no, just say I'll research that and get back to you, right?
I've been in sales too.
Yeah.
It's really astounding the distance between like the first big shuttle, synthetic aperture radar, which took up the entire payload bay of the shuttle, about better than the size of a school bus, and what you guys have. It's just incredible.
Yeah, we did some rough calculations. I was with a customer who happened to ask an interesting question. How many could we fit on a single Falcon 9 launch? And I think the number ended up coming out between 95 and 100 if we wanted to buy the whole launch of our little satellites.
And did they just float around or they're powered? You say you can flip it. Sorry, I'm just curious about like the most basic physics here. Like
Yeah,
you
so
say you
we
flip it,
do
how
have
does it have power. Yeah, go on.
Yeah, so we do have thrusters on board that again enable us to move it a little bit and then to maintain our altitude. One of the major downsides of being in low Earth orbit and being a big antenna system like we are is we suffer from drag up there. So we have the capabilities to adjust and make sure we maintain our altitude for that.
You mentioned,
Go ahead.
oh, sorry, go ahead. At some point you mentioned I don't know if you wanted to launch more to get higher revisit rate. Are you planning on doing lower inclination satellites or just more in polar?
I think more. Changing our inclination is going to depend on, again, demand.
Okay.
Our company on the business side and has taken an approach that we will build it, we will fund it, we will hire based on demand and not based on assumptions of what demand might be down the road. So as we build that, maybe there is a demand where we put these in mid inclination. I know SpaceX recently announced their another one of their ride shares that would go to mid inclination, the bandwagon program, I believe.
Resray, go ahead and jump in.
So about your thrusters, what kind of propulsion thrusters are you guys using?
I am unsure. Again, that would be another one for the engineers and the guys building this.
Because I heard about there's this sorry to interrupt, but there's like this technology, I don't know if they're still working on it, but called like ionic thrusters or something, where it
All
uses
thrusters.
a Hall thrusters. Hall?
Yeah, I've seen I've seen some infographics at some of the conferences about different thruster technologies coming on board. Again, I can't speak to the engineering side of what goes into our birds.
Hall thrusters? What was it called? Hall.
HALL.
Okay, let's
And
move on.
NASA's actually used them for deep space missions like the asteroid rendezvous and things like that.
Yeah.
And also JAXA, the Japanese, kind of pioneered it.
And it allows
Do
you
you,
to
can
make
you,
the
do you know
satellite
if you're
smaller.
using for pointing, since you have to point frequently, or using reaction wheels?
Oh, I'm
Gyros,
sure we are.
basically.
Again,
Yeah.
that's beyond mine. I like to tell people occasionally that I might be one of the top 5 dumbest people at Umbra, just because I'm not an engineer, I'm not a scientist. I know kind of what goes into making a really nice picture from space, and in other forums I can tell you what Russian tanks look like on SAR, but these slides here are going to kind of depict our general tasking process. And again, if you guys want, at some point I can show Canopy, which is our customer facing UI, and how we go about tasking our satellites, or how customers would go about tasking our satellites. But essentially, you task scene size. Currently, we provide a 5x5 footprint or a 10x10 footprint, and then not on this slide. I should have probably updated it. We have what we call the natural footprint, which is everything you're getting in that footprint. However, outside 5x5, just by the way the energy comes back to the antenna, you're going to get some bleed off for resolution on the edges.
Yeah.
5x5 is really where you're going to get the max resolution out of our system. But with that, as you task, you'll get to choose your resolutions. Again, we have commercialized down to 25 centimeters. We let you pick what you want. We do provide some documentation, best practices sort of thing for customers who might not be as savvy with synthetic aperture radar. From there, we allow you to choose multi-look. Multi-look factor is an increased dwell over a target. That increased dwell is going to help reduce speckle, and it's going to aid in the visual interpretation. If you look, the image in my background here is of London. This is a single look, I think 50 centimeter shot, so it's going to have a little bit more speckle, and it's an early product before we start doing some improvements to our post-processing. And then the shot that's on the slide is a 3-look 40 centimeter shot of Saudi Arabia. So the blacks are richer, like everything kind of pops better. Additionally, this might be a colorized sub-aperture image where to help those man-made objects show up a little bit better. And I have other examples of that later on.
What's the centimeter thing measuring? I'm confused about that.
So that's the resolution. So each pixel is equivalent to 50 centimeters on the ground.
Oh, interesting. Okay.
I
I have to wrap my brain around that. That's cool though.
Yeah.
Is that the center of the center of the image, and
I
then
believe
you
so.
give a range from one end to the other?
Yeah, so as you go out, just by the way the energy is coming back to our antenna system, the resolution is going to fall off on the edges past 5x5. From there, we allow you to pick your format. If you are just looking for lower resolution, a GeoTIFF suits your fancy. Awesome. If you are really into this, you want to dig down, build out algorithms that get deep into the raw data. We offer what's called a CPHD or a CRSD. Those are as close to raw as you can get with our systems. And again, so this is a better version of what I was telling you guys about the color sub-aperture. The color sub-aperture is a product we brought out last year, or early this year, late last year, early this year. It actually takes the phases of our data, our synthetic aperture radar energy goes down and then comes back in pulses. So we're actually able to separate those out, colorize the different layers, different colors, and then put them back together into an image. What that does is as the energy has gone over a target, as it flies over, different objects are going to produce different signatures, particularly man-made objects, objects with corners on them. This is extremely useful if you're looking for man-made objects in, say, tree lines. I'm not saying there's a use for that, but maybe there's a use for that if you're looking for things of that sort. And it looks really cool when you image things like bridges where you get multi-bounce and a whole lot of different things.
So your raw product, like ESA has a whole set of synthetic aperture radar tools for use with Sentinel and other data. I think the Alaska Space Facility has, a set of tools for et cetera. Is that file format picked for compatibility with those?
I'm not entirely sure. One of the things coming up for my position is to start working a little bit more with those folks and figure out where the compatibility is with their tooling. A lot of our customers are utilizing things like ArcGIS or QGIS. Remote View, Socket GXP from BAE for their analytics, or if they're utilizing raw stuff, they're going in and getting SARPy and building algorithms to process the data themselves into different products.
And your goal is just more and more depth and clarity, like you say, in the mission, right? Like it's just give a better signal.
Yeah.
And understand, I guess, to that point, right? Why people are using it for what, but your job is just clarity, really, right?
Yeah, clarity and the two major benefits of synthetic aperture radar, and I should have probably opened with more of this, is that because we're not an optical sensor, we are not handcuffed by nighttime or by weather. These are all weather and daytime, nighttime sensors. So if you're looking to maintain custody of an area or want to look at a place when that may have bad weather 6 months out of the year, or is dark 6 months out of the year, we are the sensor for you.
Venezuela.
Yeah, and this here is just another example of the multi-looking. You can see on the red highlighted box the high signal noise ratio from the multi-looking, and the contrast between that lake and even the drainage ponds there, and then the road systems as well. This has been an awesome thing that our team has done. One of the benefits of the commercial world, if anybody's had experience on the government sector, is sometimes bureaucracy and things slow things down on the government sector. We don't have that problem in the commercial world. Customer comes to us with a problem, and we are able to rapidly innovate and come up with solutions to solve the problems for our customers. And the multi-looking was one of those things. We are currently able to multi-look up to, depending on the resolution, up to 10 times, or like a 25-second dwell over that target, which just gives you a ton of information.
Resrick, what do you got?
You probably said this already, but what exactly sensors is it using to, like, scan the area? I'm just more curious on that part.
Yeah, so it's using X-band radio waves. The way synthetic aperture radar works is our radio waves are transmitted from the satellite. They bounce off things on the ground, and then the energy is returned back to the satellite, where the onboard computer system creates an image. My family, I've got a 17-year-old son, and the way I explain it to him is it's kind of like a fish finder from space. If you've ever worked with a sonar or a fish finder, it's the same concept. It's shooting that energy down, bouncing off stuff, coming back, and making a picture for you.
Does that mean it's mostly bound to kind of depth and like topology, or is that what it mainly sees, is differences in depth or thickness, or I don't know.
You're seeing the return of the objects on the ground. So the energy is going to go down there and, like I said, bounce around, do what it's doing. And yeah, you'll get some depth out of it. I don't know if this slide deck has some of the mining studies that we've done. These deep strip mines where you can see the swirls going all the way down. Some really cool stuff. But it's, yeah, whatever's down there, that's what the energy is bouncing off of, and then it comes back and creates an image based on the energy returning.
So one of the important differences between SAR and we normally consider as an image, aerial photograph or image from space, is synthetic aperture radar shoots down at an angle, right? So I don't know what your particular parameters are, but it's not going straight down and back up. And
right.
That leads to is kind of a distortion of the field of view as it's presented on the ground. So things that are really close are going to appear more or less straight up and down, but as you go further, you're almost looking at them from the side. So if there's a lot of terrain relief or buildings, what's behind them will not be seen. That's called layover.
Right.
And
Yeah, and,
the
and
Holy Grail
additionally,
is.
the energy does funny things depending on what's on the ground. Like I said, the tall buildings causing layover for the things behind them. One of my favorites is how sometimes fast-moving large objects, say trains, are projected outside of where they're at, where the train tracks are, and that's just a phenomenon based on the satellite and the energy moving over while that object is moving as well. So I don't have a good example of that, but it's always fun to see train tracks, but a blurred line, 50 meters off to the left, and know that, okay, well, that's a train. It just offset due to the way the satellite and energy is moving, and then that object is moving.
And would that be on you guys to fix errors, quote unquote, like that?
No, that is it's one of those things that's really not fixable. It's one of the things that comes into the tradecraft for the analysts, and then for the engineers who are building the analytics products.
It's actually a feature, not a bug. Because
Right.
if you're interested in moving things,
If you're in sales, it's definitely a feature.
I like to say I'm not in sales. I'm the kinder side of our sales team, a little bit. Taking a look, we were talking a little bit about our derived products. This is some of that fortuitous change detection. This is lava fields in Iceland on the left.
cool.
And this is recent, as of early this year, the volcano erupting in Iceland. We're able to actually track the lava flow, track the vessels leaving port and coming into port. I was talking a little bit earlier about the cross-track interferometry. This is just two satellites coming over at different angles, collecting that data. I'm not super versed on the phenomenology of what goes on in the science part of the image on the right there. I'm sure I go back and talk to one of our SAR scientists, and they would explain it in a couple seconds.
Basically, you instead of one camera, so to speak, you have two cameras.
We have two cameras.
And just as two cameras give you a stereo effect, with radar, since you're looking at if you look at the same point, you'll get two different sorts of signals that you can then, just like two strings on a guitar, they'll interfere with one another, and where they're the same, you'll get that contour line effect. It's really useful.
Awesome. I'm glad somebody is able to talk to that part of it. I've always wanted to be an image scientist. I've just never made the jump to spend that much time behind a desk at school. So, and like I said, on the left, amplitude change detection, we also call that in the biz two-color multi-view, where the blues represent new objects between two images, and then the reds indicate something leaving between two images. We say blue is new, red is fled. Very useful. The amplitude change detection or two-color multi-view. If you have not very well trained analysts, if you're looking for large amounts of objects moving, say in the build up to a combat scenario, that analyst can quickly go through and say, okay, 50 set objects arrived, 150 departed, put together their analytics product behind that, and hopefully go win the war. Alternatively, on the commercial side, this has benefits if you're looking at commodities, monitoring port facilities because you're wanting to invest in certain products. Same concept, right? How many things are arriving, how many things are departing, and then you can bet Vegas style like on that.
Or crops.
Right. Or crops. Yep. Crops are a big
when
one.
When it rains, the soil changes dielectric, so you can, to some extent, look at things like soil moisture and events
Yep.
like that.
Humanitarian relief, this scene in Iceland particularly, monitoring that lava flow. If you have weather come in, hurricanes, tornadoes, same thing. You can monitor the water coming in and then the water receding, damage, all of that.
Resrick, go ahead.
Yeah, so in that last presentation on the right side with all those wavy lines, was that the radioactivity from the uranium messing with the radio waves from the satellite?
No,
And
so
that's why
that's an actual visual representation of the energy, I believe, going back to the satellite pre image formation.
I was just wondering if that had anything to do with the radioactivity.
You shouldn't. Do a little bit of the sales pitchiness, future modes that we're looking at with our systems. As I talked about earlier, right now we offer spotlight mode. However, we understand that for some of our customers, 5x5 kilometers is not optimal for what they're looking for. With that, we are working on a strip map mode. One of the trade-offs with larger area is going to be lower resolution. But even then, we anticipate being able to achieve high resolution strip map modes. This is outside Phoenix, Arizona. This is one satellite, one pass as it traveled through the area, 10 kilometers by 120 kilometers at, I believe this one was a 1 or a 2 meter resolution. So we're not going to find super small objects, but if you're looking for vehicles, if you're looking for things like that, this is still going to pick that up, and you're going to have a larger area to look through. This comes in handy when you talk shipping traffic, maritime domain awareness, monitoring port facilities, anywhere that you really need large areas. And where that 5x5 kilometer just won't suffice.
Kyle, could you quickly just high level me on pricing and how it works? I mean, I imagine you pay for resolution and things like that, but if I'm like ordering or tasking the satellite with whatever, can you tell me at a high level, like what I need to consider if I'm cost conscious and trying to get what I want, but like what are scenarios where I'm like paying a ton of ordering a task to do it? If it's like, who knows, if it's like travel distance and things like that, like how does pricing work? I'm just curious.
Yeah, so resolution and time are going to be the two major players when it comes to cost, at least for our systems. So and sometimes higher resolution equals time. So a 25 centimeter shot takes longer to collect. Therefore, we have to recoup that time that's spent on an area. Same thing with the strip map modes. We can go higher resolution. However, high resolution over 125 kilometer strip, that's when things start to add up cost wise. Now, all of that is relative. I could pull up our website and what is a high resolution long dwell shot. We don't consider to be super expensive. Again, that depends on where you're looking, or where you're coming from as far as what is expensive. If somebody was to come to me and say, hey, your imagery is too expensive, generally I would challenge them to take a look at electro-optical imagery or one of the other synthetic aperture radar providers. And I think generally speaking, you'll find very quickly that we come in way under our competitors on both of those phenomenologies.
And you said that each satellite can take a picture of any point on Earth twice a day. Is that what you said earlier?
Ish. I mean, we're on that polar orbit, so we don't get as much repeat of every place on Earth, just because the birds only drift so much while they're up there. Generally speaking, I can hit most places on Earth twice a day, ish. Again, sometimes it just depends. If you're in those mid inclination, those mid orbits, we're not going to be able to hit them as much. If you I have a customer now who's doing penguin research. If you're looking to image Antarctica and near the South Pole, I can hit Antarctica probably 3-4 times a day per satellite. The closer we get to the poles, the more access we have per day per satellite.
And do you talk about how many satellites are in your fleet, or is that?
We have 5 currently. Again, we have 2 more going up on SpaceX rideshare soon. And then I think the intention is to put more up next year, at least 2 more up next year.
Cool.
So are you anticipating at some point in the future, polar orbits have, they're they're built-in grief, but geodesic orbital constellation like Iridium uses, or of course the Tesla product and the etc. Now you then have to possibly a lot more satellites, and it's non-trivial keeping track of all of them.
Changing our orbit and inclination is all going to come down to demand from the customers. We are continuing to grow the commercial sector and build on the commercial customer base. And then our government customers as well. If we get that demand signal that says customers are willing to spend X amount, I don't know what that X is, to have better revisit rate from mid incline, then I believe our sales team will take a hard look at that and decide to put satellites in that orbit.
Or 100 of them all at once in
or 100 of them all in total orbit. I think it would be fun. One of the other modes we're looking at is a mosaicing. I think we're a little bit closer to mosaic. This is going to essentially a series of high resolution spotlight modes. I don't have the image here, but we played around and we were able to image the entire Panama Canal in a single pass with a single satellite, which was pretty awesome. The mosaicing is going to give you a little bit more flexibility, in my opinion. So if you're really looking at coastlines or riverine areas or say major highways and roads, it's going to allow you to task the satellite around those lines of communication, so to speak. And I hope this is going to be a product that we have out before the end of the year. Same thing with the strip map mode. Looking at some really juicy stuff that we've been working on, bistatic and multistatic imaging. I refer to this as the bounce pass imaging. So we have 2 satellites. Our last 2 satellites we sent up into orbit are in a paired formation. A certain number of kilometers apart from each other, but in a paired formation. The bistatic, multistatic, again, I call the bounce pass because essentially what the bistatic is that first bird is going to come over a target. It's going to transmit. That second bird is going to come over and it's going to receive the data. And then with the multistatic, it's similar in that first bird is going to come over and transmit and receive. That second bird is also going to receive the data. So you're going to get a little bit higher resolution off the multistatic. With the bistatic, it really comes in handy, say, possibly in contested environments. If you're a government customer and you're afraid that maybe you're being jammed on X-band in an area, then we can utilize something like bistatic to, just to give you some more diversity there. But the bistatic is really cool. We are currently the only provider launching satellites in a paired formation. Our next 2 birds are going up in a paired formation as well to allow this. Michael, we were talking earlier about things like DEMS and more interferometry. The paired birds are going to hopefully open up some more of those capabilities for us.
So basically your bistatic is similar to the Tandem X with two satellites following one another.
Yeah. And again, our goal is the rest of our constellation from this point on, and especially at least the next two birds will go up in paired formation like this to open up the art of the possible. We'll put them up there. We will image, and then we will leave it to smart people on the ground to come up with uses for it down the road. Yeah, again, the elevation modeling, imaging resilience, moving target indicator is another thing that we are playing around with a little bit. This is a technique that I call the double tap. That first bird in the formation comes over, images an area. Between 10 and 30 seconds later, that second bird comes over, images that area. Because they're on the same track, we're able to put those images together into a change detection product and get moving target indication off of that. Super beneficial, again, for your maritime domain awareness. Tracking vessels on the water is a big use. We are continuing to talk to customers and work on other uses for moving target indicator.
So
Go ahead.
do you know how precisely in time does the satellite know when the image has been captured?
So
Precise.
we keep track through our ephemeris data of where the birds are in flight. So right now this is a manual process for tasking them. The birds don't know to automatically task, hey, that first one shot, let's shoot the other one. But because we know where the birds are, we're able to manually task those, and they come in with similar geometries to be able to do that change detection.
I have kind of a non sequitur question here, just about, I guess, separating like civilian or commercial uses, or really kind of commercial uses from military uses. I'm just noticing in the bottom left of your slide, you've got Umbra Public, but I guess the question is like, how much of a challenge is that? I would just think that they're two very discrete audiences.
They are and they aren't.
Okay.
I think taking a look at the penguin study that one of my customers is working on, utilizing synthetic aperture radar to look at medium to large groups of objects, right? I think that's got a neat science and commercial use. But then you take that and you could if you were able to sell to the government, hey, I mean, one meat puppet is as good as another, right? I mean,
Yeah.
Yeah, go ahead.
Who was that other partner that you and I spoke about, Kyle, that was on here speaking? Oh, Skyfi, right? Is like, you mentioned that Skyfi, for example, who's been on Space Data Hackers previously, they are a consumer of your imagery and kind of resell it. And they, like we said earlier, your guys' job is just more and more clarity, more and more capability, et cetera. And then the uses and application side of it to me seems endless. And
Yeah.
it would seem like it's better to be on your end of the equation, providing the, backpacks and shovels and everything for the gold miners than.
Yeah, and there are companies out there that specialize in selling the data and building analytics products on top of their data. I think one of the issues you're going to get into with a business model like that is now you're competing with your customer, right? And that's just not really a good way to play ball, in our opinion. And that's why we've decided to be the shovel provider, and let somebody else build the wall or build the building out of it.
Cool.
So as the Sarvangelist, you have a kind of a chicken egg problem, that you need that demand signal to expand. But like synthetic aperture radar is coming from a, kind of a remote position in the marketplace. Have you contemplated like maybe having a hackathon or something to get the college students and, basically the academics, et cetera, other scientists, building use cases, that can demonstrate some of the capabilities. And
I don't know of any discussions internally about doing something like a hackathon. What we have done is provided, again, almost 5,000 images into an open repository that we continually, push out on social media and let folks know. One of the other things we've done for that open repository is we have a link to, I think it's a Google form. If you have a place on Earth that you want to see imaged with our imagery, fill it out in the Google form. We'll go through, we'll image it, and then we'll send you the image and publish it on social media, thanking you for submitting a location. And
cool.
yeah, and the link to that Google form is on any of our social media, LinkedIn, Twitter. Our marketing team absolutely crushes it with things like that. People like to see their hometown imaged and see what it'll look like on one of our pictures. And yeah, they've done a really good job. Outside of that, the open data program has been huge. Again, we've had folks go in there, pull a year's worth of imagery over a single target and run change detection and run different algorithms. We've had folks build businesses off of our open data program, which again is beneficial not only to the community, but it's beneficial to us. They go out there, they build it. We encourage folks to go out there and build stuff off of our open data program, and then hopefully we can bring them back into the fold once they built that business or built that algorithm as a customer, or feed them to our partners and Skyline as a customer.
What came to mind was a couple of years back, I did a National Security Innovation Network, a DoD hackathon about wildfires, right? Which are obviously just becoming a huge problem in my research peripheral. But the big issue is when nighttime occurs. It's really, sounds surprising, it's really hard to see a wildfire and know what the heck it's doing, especially overnight.
Sure.
And if, for instance, be curious to do some, what can I see, open, what can I see, etc. And that would be an example of an exploratory thing that might create just vast demand for the imagery, especially high read.
I can see that. When I get off of here, I'm gonna put into our Slack channel. Hey, what are our thoughts about a hackathon? Something else I've been considering is a community of interest, SAR community of interest.
Yeah.
Maybe something like your guys' platform where once a month we get all of the nerds together who are interested in synthetic aperture radar. Maybe Umbra can talk about what cool products we're coming out with, but then, more importantly, find out what the community is doing and what the community wants, which has been really the basis of my position here at Umbra, is going out there. Yeah, I evangelize a little bit, but most importantly is finding out what the customer wants, what the analysts, what the scientists want. Because if we're building just what we want, then we're doing a disservice to the rest of the community, I feel.
And Kyle, we definitely want those kinds of subgroups and special interest groups and stuff to form. It's my experience with this space topic over the last year has been, it's vast, not surprisingly, right? And so, yeah. I mean, you can go deep on SAR, obviously. So I think that's kind of what it's like now, but this has been fascinating. It's cool.
Yeah.
So what we're looking at now, I'm just go back real quick.
Yep. So this is a change detection product utilizing our paired formation, our formation flight. This is China, I believe. Yeah, Yangtze River in China. So just like before, the blue is a new object. The red is a object that departed since the last imaging cycle. And for this, it's within, I think, 10 to 15 seconds as those two satellites fly over and collect the imagery. So you can really see where ships are moving in and out of that port facility. Again, if you're tracking commodities, you're tracking things coming in and out of ports, throwing your Vegas style bets in there. Products like these are going to be influential to how you possibly bet or invest. I shouldn't say bet, invest.
Another one I did was with Sentinel SAR was somebody raised the question about the lumber marketplace because during COVID, all the lumberjacks went home, etc. And they wanted to know what the supply chain looked like. Well, lumber is stored in these big 4x4x12 plastic wrap pallets. Those show up on radar really, really good. And the logs too, the log files and things like that. So there's all sorts of supply chain commodity things that are now possible.
Oh yeah. Yeah, and as we increase our constellation, we're able to get better repeat ground track and repeatability on these. Those type of products are only going to get more accurate for our customers as they build them. With that, that's the end of my slides, my actual official slide. This is Jeddah and Saudi Arabia. This is one of those 10 times multi-looks. This is a 20-second product. We shot when the F1 GP was in town there in Jeddah. And then we put the colorized sub-aperture on there. So you can see all of the glint and the color coming off the different man-made and metal objects down there on
It
the
is
ground.
beautiful.
Yeah.
So is the chromatic effect in that image along or related to the track, or is that something happening which is differences between the looks?
It's the differences between the looks or the phase, the returns coming back to satellite. So what we do is we colorize those, and as the energy comes back, over those long dwells, and we've kind of sandwiched them all back together in different colors. As the bird comes over, different areas of energy are going to show different glints and different colors.
Well, thanks.
We post a lot of these on our social media, mostly because they look really cool.
Feel free if it's not a ton of work for you, just paste us in the Zoom chat some links to whatever. We can click around. But yeah, hey, thanks for the talk. And I see Resrick has a question. He says, do you guys do programming basics and in real life meetups? I'm guessing, Resrick, I'll try to answer you directly if you wanted to just talk, but help me understand your question if you don't mind coming off mute. I don't think there's in real life meetups for space data hackers, but this broader group in Seattle, Michael Patrick could probably or June could speak to it better than me. I'm kind of from the online side of the house here, and but there's definitely a local space enthusiast group in Seattle area.
Yeah, Resrick, save some time in your calendar, October 5th and 6th this year. Come to the Space Apps Hackathon in Seattle. I know Michael and the other Mike, and hopefully Eric will be there as well. I'll be there.
Let me note that.
Is that
Again?
June something that's out there as a web link yet that you could paste in, for example?
Yeah, Mike Doyle had something sent out last month, but let me find it.
Yeah,
Find it before we.
Mike Doyle's traveling in Greece, so
Yeah, let me find something and I'll post it here before we adjourn.
I'm not sure if this screen is sharing. Is it?
Yeah.
Yes, it is.
Okay.
Yes.
I just kind of want to show if we have time, and feel free to stop me and tell me to shut my mouth.
No, we're good. We can
Okay,
go till half past, so we just
Perfect.
chill. All good.
This is our customer facing UI product we call Canopy. Like I said very early in the presentation, we have tried to make tasking satellite imagery easier than booking a hotel room. And it really is super easy. Be able to go in here, say Caracas, and there's a ruckus there after the elections over the weekend. You choose your area, hit enter. It's going to highlight that light circle is going to be the guaranteed 5x5 or guaranteed imaging area. The outer area gives you just a little bit of bonus. From there, we're able to pick our resolution and our multi-looking from there if we wanted. Scene size, like I was telling you, we have natural footprint and a 5x5. If you are a power user, we do give you the capabilities to come in here and change azimuth angle, grazing angle. If you're looking, you really want to see into a airplane hangar or something, and you want to change to a low graze with a particular azimuth angle, we allow you to do that.
Very cool. That's awesome.
I'll reset that. If you are looking for something particularly and want to change your polarization, we allow you to do that from horizontal to vertical, and it actually shows you how the energy is going down off of the satellite from there. And we give you little tips as to why you might want to use that. HH or horizontal mode is good for helping distinguish built structures from natural surroundings. The vertical VV has a diverse range of uses in remote sensing. But if you're a power user, we give you those tools and let you do it. We give you, recommended parameters, but we let you go forth and play once you've been told what the recommended parameters are. And then it's just as easy. Put your date group and hit the search bar. Our scheduler is robust. It runs on a 10-minute cycle. It's going to pop up and give you the feasibilities for the next 7 days. Now, I was messing around with this. Again, I mentioned my background is in analytics for the government. So when I saw that there was a hosed up election in Venezuela, I tasked this the other day, which is why we're seeing less feasibility over the next few days, because I already have some tasks submitted, so I can play with those myself. But then, yeah, just as easy, and it's going to tell you, what the constraints are that are going to be in there, how long your image is going to be. Simple as adding to the cart, hit schedule.
So could I upload a shape file, for instance, and then see the orbital path and the raw image boundary to make some decisions?
So I don't believe you can upload that. We do utilize spreadsheets via our API. So if you want a bulk task and really know what you're looking for from that, our API allows you to have all those tools at your disposal. If you work with a partner like SkyFi, they've done a really good job of replicating APIs for tasking as well. Excuse me.
So you sell through SkyFi?
We do work with SkyFi. They're one of our partners here.
Who else? You have any others like Skywatch or anyone else? Or
not off the top of my head. I believe we have a partnership in Europe with UC. SkyFi is our big one here for the US side. And SkyFi's platform is fantastic. Not that we would rule out working with other partners. It's just that's one we've been working with for a while as they've built their platform over the last year and a half or so.
and if I come in through SkyFi, can I do everything you just showed me here, including the changing of the angles and all of that, or is that too set?
Yeah, so they recently rolled out the things like changing azimuth angles and graze angles to their platform. They've done a really good job of replicating what we're doing. That way, there's a seamless transition. And with that, again, I'm not a business guy, but I know enough to get myself in trouble on the business side. We've taken some stances and staying small. What we're not doing is hiring a bunch of salespeople. So if you are only looking for onesie twosie shots, you're really better off going through a company like SkyFi, who has the capability and the sales force there to be able to handle 1 or 2 images a week, 1 or 2 images a month, or maybe even just 1 or 2 images, and they'll be able to take care of you and square you away. Whereas, we're kind of trying to go after on our side some of those bigger fish, so to speak, and let our partners handle some of the
broad market. Yeah.
And again, by doing that, we're able to stay small. We're able to keep things affordable.
So you kind of assume that your big fish are sophisticated users for the most part.
Yeah, so I mean, I don't think it'd be a huge secret to say that as a U.S. Satellite imaging company, that the U.S. government's one of our biggest customers, and those folks tend to be pretty savvy. They know exactly what they want when they want it.
Yeah, I was just curious, the big challenge with the Earth observation market, overall, is that it requires a significant amount of sophistication to use the data, when mere mortal business users just they don't care where the data comes from. They just want to know, what do I need to do to solve problem X?
Sure.
And so I'm just curious how you think about that internally. If you want to get to expanded market, and SAR is even harder than imagery because we kind of know how to look at images, even though we don't. So if you want to, in the long term, get to a much larger customer base, do you see a lot of intermediaries between you and end customers that are coming in with a vertical solution that solves a particular business problem that may use SAR data, and they become an intermediary even between someone like Sky-Fi or you and the customer? Is that not something you've heard discussed internally?
I mean, it's in the art of the possible. And I'm sure there are customers that we've referred out to, like Sky-Fi's, who are doing just that. They are
Okay, they have services people and they
Mhm.
okay.
Yep, and Sky-Fi every day is and then not to give a sales pitch for Sky-Fi, but they're coming out with new things every day. They're putting analytics over data, not just ours, but over planets and
Okay.
other imagery platforms. But then they're continuing to work with analytics providers.
So,
Um,
oops.
Go ahead.
So how about your international competition, the Israelis, the Indians, the Chinese, et cetera? We're obviously not the only people putting up platforms, et cetera. And you made a large capital investment in the platforms you have. Do they stand a chance of superseding you? Sometimes it's the second mouse that gets the cheese, so to speak.
Sure. I hope not. Kind of the second mouse thing. There were two other American providers on the market before we came on the market commercially. And again, not personal opinion. I think we're crushing it. And then the American market. When it comes to the foreign market, we'll kind of take that on as it comes to us. We are, we have taken stances that we don't sell to adversary countries. So, an analytics company or a researcher in China or Russia or Iran,
Or California.
or Cal. No, we're based in Santa Barbara, so we'll take care of folks in California. But those adversarials, those near peer countries, if you're talking about the government side, we've taken stances to not sell data to those countries, and we go through a very robust vetting process to ensure companies that we are partnered with aren't utilizing that data in a way that would harm frankly some of our biggest customers, especially with the U.S. government.
What does the regulatory side of this look like? Kind of just, again, like a 101,
Yeah, there's a lot of regulations. One of the things that we did going into this is, before our satellites, while we were building our satellites, the NOAA regulations said that American companies couldn't sell imagery that was 25 centimeters. They couldn't be better than, I think, 50 centimeters. And where we do a lot of things differently. We built our satellites with the intention of fighting regulations and working with the government to get regulations changed. And we did that. We were able to get it down to 25 centimeters, and then last year NOAA lifted the lower end of that. So really we could go as high resolution as we want now, and we've tested 16 centimeter.
Cool. Any other questions from anybody? We don't have to be here all night, but definitely open for additional questions if there's any.
Sorry, Carl, Roger here. I came in late. I didn't catch some of your beginning. I'm just interested in the size of your payloads and sort of power requirements, and whether something like a high altitude UAV could do something similar, or is a satellite just that much more grunty, I suppose?
Yeah, so I think our antenna is able to is a big difference maker for us. 3.8 meter antenna at low Earth orbit, currently about 550 kilometers in low Earth orbit. And I don't think, and I don't honestly know a lot about high altitude drones, but our payload is about 70 kilograms, so it's small. It's a little guy, but I don't know what airborne platforms out there are able to do similar.
So there's only one probably, and that would be the Sky Dweller. There might be others coming on board. Okay,
fair enough.
NASA over the years and DoD have had airborne SAR, projects from near ground level all the way up to stratospheric long endurance. So it always that trade-off of capabilities kind of makes the space segment the most favorable. It can't be mostly because it can't be messed with by all the other things, like even though weather won't affect your SAR image, it can affect your sensing platform.
All right. Well, any other questions from anybody? So just a couple quick reminders. Next month, August. Hope everybody's having a good summer. But yeah, next month we're gonna have, I'm sure, people from Mike Doyle's network and AWS presenting on AWS point of view about space and all that. So I'm looking forward to that one, being local. And I worked for Tableau Software, and our CEO, he's over there running AWS now, so that's kind of a small world thing. But yeah, hey, thanks for everybody's time tonight. And Kyle, awesome job and super fascinating stuff, cool technology. You're lucky to be working with such high tech. It's neat.
Yeah, I appreciate you having me.
A pleasure.
Go ahead.
Thank you much, Kyle. That was awesome.
And again, feel free to reach out. I'm on all the socials, Twitter and LinkedIn particularly. If you have a place on Earth you want imaged, I can make sure that gets to our marketing department, and your spot will get posted on social media.
Okay.
Good job.
Thank you.
Kyle.
Well,
Thank you for
everybody.
diving into the
Personally, I was just in it just to look at different groups, but it does sound kind of interesting.
Thanks, Roserick. Thanks for joining. We'll be in touch. Thanks, everybody. Have a good night.
Thanks, y'all.
Bye-bye.
Thank you.
Bye-bye.
Right.